Hello friends, welcome to Machine Learning Mastery series with Nkool Marwadi. So basically, this is the first episode of Machine Learning Mastery series. So in this video, we will be building our first machine learning project using Python. So definitely, I will be typing each and every code and I will be explaining what it is about. So definitely, you can do the coding along with me, and we will be using Google Colab for our project. So no need to install any software or any IDE on your local machine. So we can directly just create an account. So Google account you already have. So you can very easily use Google Colab to make this project along with me. So let's get started. The main question that should arise is what project we will be making. So as we have already seen, we will be making our first machine learning project using Python. But what that project will be? So now let's understand that what machine learning algorithms we will be implementing. That let's discuss. So the project is classification of iris flowers using machine learning. So we have already seen iris flowers. I hope you have already also seen. I have personally seen iris flowers. See, iris flowers can have different varieties. According to the problem statement, according to the data set we have, the iris flower can have three classes. So the iris flower can either belong to iris setosa class, iris versicolor class, or iris virginica class. So these are the three classes uh, to which any iris flower can belong to. So we will write a program that will take iris flower as input. The features of the iris flower, and it will classify. So it will tell this particular input, the flower, it belongs to which class. So it is a multi-class classification problem. Why multi-class? Because we are dealing with three classes. So the class can be any n number of classes, but in the current project, we are dealing with the three classes, as you can see. So it is a multi-class classification problem. The input will be the features of the iris flower. So what features we will be dealing? So the data set we will be dealing with. So that will be the input. The input will be the data set containing the features. So what features it will contain? Sepal length, sepal width, petal length, and petal width. So these four features we will be getting, and we will be first training our model. So that will be a supervised learning. So in machine learning, there are two very important concepts that you should know: supervised and unsupervised. So in supervised, whatever training data we have the input also and the output also. We know beforehand the input and output. We train our model. So we feed both the input and output, and our model will our algorithms will establish a pattern. So it will identify the unknown function. Now once we have that unknown function, that pattern, now whenever I will pass any random input to it, it will give me the correct output. So this is the idea of supervised learning. So in today's project, we will be making a supervised learning based multi-class classification machine learning model. So the input will be a data set with four features. We will be experimenting with different machine learning algorithms like logistic regression, support vector machines, and many more. You will go through it. We will compare accuracies also, and output will be the class to which that particular input will belong. So this is the agenda for today's this mastery session. So let's get started with the project. Okay. So I have divided. So whenever you make any project, you have to follow a life cycle, some series of steps you have to follow. So for this particular project, I have divided it into six main steps. So the first step will be configuring runtime environment. So definitely we will be doing machine learning. So we will be using many libraries. So that we call as runtime environment. Python, in Python, many libraries. So first we will configure the runtime environment. Then we will load the data set. Very important, because we have already seen, we will be needing a data set. Then we will be summarizing the data set. So we will be getting deep inside the data set, trying to understand more about the data set which we have already downloaded. The second step, and in the fourth step we will be doing the visualization of data. As you can see, data visualization we will be doing. Okay, so that whatever data set we have, we will be visualizing it, so it will be very interesting for you. And in the fifth step we will be evaluating ml machine learning algorithm. So we will be developing six models, and we will be evaluating the performance of each and every model, and we will be comparing also, and we will be selecting the best possible model. And in the final step we will be making predictions. So yeah, so this is the flow which we will be following. So let's get started with the first step, that is configuring runtime environment. Yeah, as you can see here, we have first we have to import libraries, then we have to check the versions of the libraries, then we have to load the library. So first let's import the library. So basically for this particular project we will be using six main libraries. So let's start importing it. So as you can see, the first will be the SysMe system library. System library will be used for checking the versions. Yeah, we will be doing that very soon. And very important library, scipy. So scipy is a scientific library in Python. So yeah, it has got many handy features which we will be using in the project. Then we will be using numpy. So NumPy is basically a very advanced array computation libraries. So NumPy array, we can do lots of very interesting stuff which we can't do with traditional lists in Python or traditional arrays, which we used to have in Java or C, C++. So NumPy is a very advanced matrix kind of you can say array, only advanced array with lots of functionality features that we will be seeing also. And then we will be using matplotlib. So this library is used for visualizing the data, means plotting graphs. Very interesting. Then pandas. Whenever we are dealing with data, pandas is the key. So in panda there is a concept of data frame. So whatever, so data can be in any format. It can be in CSV format. It can be in JSON format. It can be in a normal text file. The data can be in any format. What pandas can do, pandas can read that data and it converts that data into data frame. So what is the data frame? Data frame, you can consider it is a data table like data structure. So in table there are rows and there are columns. So pandas can convert any data into a table like data structure. So that we call as data frame, and it is very very powerful. In the coming series also, in videos, and in this video also, you will be surprised with the power of pandas, the table data structure, the data frame, and sklearn. So sklearn, as you can see, machine learning models will be present in sklearn. And see, in this project, we will not be making any machine learning model from scratch. We will be just using the pre-built model, because all the pre-built models are based on standard algorithms. And definitely in the coming videos I will be taking you in some we will be making some algorithms from scratch also. We will be implementing it, so you will get a complete feel exactly how the algorithms are working. So that is very important. But in this project we will not be doing we will not be implementing algorithm from scratch. We will be just doing the plug and play, and you will get an idea of the flow which you have to follow. So see, I have imported the libraries, I am running the code. Let's see. It is first time, it will take some time, so let us be patient with this, because it will start the cluster, because this program is running on a cloud cluster provided by Google. So it is starting the cluster. Yeah, so it compiled and it executed successfully. Now what we have to do, now we have to check the versions. Let's do that. Okay, so check the versions, because see, you know that like if you talk about libraries, so all these are libraries, the libraries keep on updating, so their versions also keep on updating. So let's have a look what versions we are provided with. So I will use the print statement to just print the version, as you can see. So definitely see, I will be starting with Python. So I will be starting with Python. Python, and I am using a curly braces. Okay. Then I am using format. Okay, and very easy. Sys dot version. Yeah. So just this single line of code, it will give me the version of the Python, because see, Python is the main runtime environment here. So that's why sys dot version. Now so just copy this code, and now let us suppose I want to get the version of scipy. So instead of Python, I will write scipy. Okay, and here instead of sys, I will write scipy. Scipy underscore. It will be a double underscore. Yeah. Similarly, I want numpy, very easy. So let me just, yeah, let me copy this. Now let me just do this numpy. Okay? Very easy, very easy. Numpy. Similar, so you can also do along with me. That's why it is very easy. And if you are facing any problem, do comment me. I will help you whenever I will see the comment. Matplot. So matplotlib. The full name of the library is matplotlib. So just here we can replace it, matplotlib version. Okay. Now, so here you can see we are using this format. So how this goes? So first, let me write this code. Let me run it. Then I will explain its working, how it is working. Okay. Otherwise, you will get confused. So first, let's complete the code. Pandas. Okay. Pandas very powerful. Scikit-learn. So sklearn, we also call it as scikit-learn. So all the machine learning models you will get in scikit-learn. Very interesting. That's So we are done with all the six libraries. So let's run. Oh wow! So we can see the version. So the version of Python that is 3.7. That's great. 3.7, and SkyPy 1.7.3, NumPy 1.2, 1.6, Matplotlib 3.2.2, Pandas 1.3.5 version we are using, sklearn 1.0.2. So now you got to know how to print versions of the libraries. Very easy. So how this code is working is, so inside print we are using this curly brace and this format. You already know that. So what format will do, instead of this curly braces, whatever the format is a function. So whatever it will return, so it will return that will be plugged here instead of the curly braces, or inside the curly braces. So here you can see we have Python colon, and this result we got from the sys dot version. So for format, similarly this number we got from this format, and it just got plugged here. So this is a very basic working. I hope you know this. So we have printed the versions. Now what we have to do, we have to load the libraries. So now let's load the libraries. Okay, so we have already imported the code library. So in that we have some special functionality which we are interested in. So we will be loading that. For example, let us suppose from pandas import read CSV. Yes. From pandas dot plotting. Okay. So scatter matrix. from matplotlib code pyplot. Okay, pyplot from sklearn dot model selection. So train test the split. Okay, from sklearn dot model selection import cross val. Okay, so from sklearn dot model selection import stratified k4. So what all this, you will get an idea very soon. Now here we are just loading the important functionalities which we will be using in the project. Now from sklearn.matrix, so classification. So we have this. Now confusion matrix. We have to matrix. Now we have to go with accuracy score. So from sklearn. Okay. So yeah, so first we did the pandas import, then matplot, then scale and model selection. So basically, yeah. So these are some of the functionality that will be used to train the model, or while we will create the model, we will use. Then metrics means evaluating the model, as the name suggests, metrics. It will be calculating, it will be evaluating. Now we have to import the models because we have already seen we will be directly using the models. So from sklearn dot model. So first we are importing a linear model. So that is logistic regression. Now we will be going with decision tree classifier. So that is a tree based model. So element a tree classifier. Now we will be doing the k neighbor classifier model from neighbor. Sklearn dot neighbors import k classifier. K neighbors classifier. So these are different machine learning models we will be using. Logistic regression, this decision tree classifier, K neighbors classifier. So next will be LDA, linear discriminant analysis. Very important. Discriminant analysis for LDA. Discriminant. Yeah. So four models done, two more remaining. So the fifth will be Gaussian model. So that we call Gaussian nav base. Nav base. Okay, Gaussian from a nav base. Very so now let's load the final model. So that is support vector machines. Very important. So that is based on unsupervised learning. Support vector machine. SVM. So from support vector machine, in SVC. Now what this SVC, we will see it in detail. Okay. Yes. So here, if I talk about model, we have linear model, we have non-linear model, because tree model and all that, and we have support vector machine also. So now we are done with the loading. Now let's run this. Oh, great. So we loaded the libraries. So the step one is completed. Congratulations, step one is completed. It was a very easy step. So let's just move. So in the first step, configuring runtime environment, we imported the libraries, we tested the versions of the libraries, we loaded the libraries. Now let's jump to the step two, very important, loading the data set. So now from where we will get the data set? So we will be downloading a data set from a URL, because our data set is in a CSV file, and that CSV file is in a server. So we will directly fetch that the data of that CSV file from the server. We will not download the CSV file, upload it here. That all we will not do. We are yeah. So that all are foolish things. We will directly go to that server and read all the data and fetch it and store it in the data frame. So I will show you. So first let's write the URL. So the URL is https raw. So it is not the agency raw. GitHub user content dot com slash j brown data sets master iris dot s. So this is the file iris.csv, and we have given the URL. Okay. Now let's see how we will be able to fetch the data from this URL. So before that, I am making a list of names. So the CSV file, we have a data, so we will be having columns. So every column I will be assigning a name, because every column will be a feature. I will show you what this feature is about. So the names will be the features of the input. So this simple length, simple width, petal length, petal width. So let's do that. Okay. So simple. Then we have simple width, then length, width, petal, petal width. So we have it. Okay. And also the class. So the final. So class is the output basically. Class is the output. So class is the basically. So every sample will belong to any class. Here class can be either this Setosa, versicolor, or Virginica. So this is the class. So whatever data we will get, we will have 5 columns. So last column will be the class. Now let's load the data. Okay? Very easy. So we have already seen the read CSV function. We imported it, and here I will just pass the URL and the names. It's so simple. So just use the read CSV function, pass the URL and the names, and we will get the data frame. So the name of the data frame is data set. So basically whatever the data frame we will get, we will store it in the data set. And now let's print the data set to give an to confirm that okay, we got the data, and just to give to get an idea about the data. Okay. So let's run this script. Let's see the magic. So this should be names is equal to, yeah, great. So it should be names is equal to names. Now so we have the data. So see, so just one function, and it just went to that server, grabbed all the data from the CSV file, and we have it. So the CSV file has 150 rows and 5 columns. So as we have seen, so it assigned names to the column. So you can see this sepal length. So yeah, and sepal width, 5 columns, class, setosa, versinica, and different. So this is the what you can say, the data set which we will be using in this project. And so let me means introduce you with some of the very important terminology used in machine learning. So the first is the sample. So every row is a sample. Okay, every row is a sample, because every row is a iris flower. So let, if I talk about this one, I am highlighting it. So it is a sample whose sepal length is 4.9. So sepal length is a feature. Sepal width is a feature. So all the columns are feature and all the rows are samples. So in this data set, we have 150 samples. And if I talk about features, we have 5 features: length, width, petal width, and class. In this way, we analyze the data set. So now we just loaded the data set. Now, so step 2 is completed. Congratulations. I feel it seems to be interesting to you. It's very interesting actually. Now we will be summarizing the data set, means we will be trying to decode more, get into more about the data set. So the first very important concept is the shape. So first let's print the shape and I will tell you what is the meaning of the shape of the data set. Okay. So very easy, just use print and data set, because the variable holding the data is data set. We have already defined in the previous step. Dot shape. So it is a data frame, which basically pandas data frame. Just one line. Let's try to run it. Oh wow. So we got the shape. So see, very important concept. So whenever you will load any data set, so it is basically a data frame. So every data frame has got a shape. So what is the shape? Number of rows, comma number of columns, or number of samples, comma number of features. So we have already seen in our data set we have 150 rows or 150 samples. So that's why 150 comma 5 features we already saw. So 5 columns. So 150 comma 5. Very important. So shape, you got an idea of the shape. So whatever the data set we are having, its shape we printed. Now let's peek into the data set. So what is the meaning of peek? Peek means uh, we can look into the data. So with peek, we can look into the data. How we will do that? Let me show you. Very easy. So data set dot. So there is a function called head, and whatever number you will specify. Let us suppose I specify 30. So I can peek 30 rows. So you can see I can pick from 0 to 29. So it is 30. So 30 rows I was able to peek. So that is peeking the data set. So there is a function called head. Just specify the length. So dimension of the data set, peeking the data set. Now we will be doing the statistical summary of the data. Very important, very important. So this is called data analysis. So whatever data set we have, we will be analyzing, means we will be calculating the mean, the standard deviation. So these are some of the statistical features we will be exploring, analyzing. So that is statistical analysis of data, or we also call it exploratory analysis. So that we will be doing. Okay. So very easy. Let's start. So just one function. So you might be thinking, okay, I have to calculate the mean. I have to write a function for that. Standard deviation for a function, minimum, maximum. So I have to write lots of code. No, Python is very friendly. Just you have to use describe. Just one function. Let us run the code. Oh, so it will be data set. Okay. Yeah, just run the code. Oh wow. Just one line of code and see, we were able to describe our data, means analysis. So how it is about count is counting. So What it is doing, it is counting sepal length. So it is telling 150. So 150 different values of sepal length. 150, 150 mean. So it is calculating the mean of every feature. So yeah, so mean of sepal length we have 5.84 of sepal width, standard deviation, minimum. So out of all the 150, what is the minimum sepal length? So that we got using this. So with this function we get an idea, because we don't know what is there in the data, but we go from the bird eye view, we can that is from the statistical point of view, we get an idea. Okay, so if I talk about the sepal length, the mean sepal length is 5.8, or average we can say that, and the maximum, minimum, all that analysis we can do just using the describe function. Now you can say that why here class is not there, because class is also a part of a column, because class only has three values, setosa and this versicolor and vernicia. So that's why we it didn't describe that. So for that we will be doing class distribution. So what this class distribution will do? First, let's write the code. Then you will get an idea about class distribution. So very easy. Just print data set dot group by, and what the column we are planning to group, class column 5. Let's run this. Yeah. So what did this code did? So whatever data set we have, we group that data set based on the class. So in SQL you might have used group by that, very important. So here also we have this group by class. So what this will do, it will return a new data frame that is grouped according to the class. So we have three classes. So our data is grouped according to those three classes. And size. So what size will do? Size will return the size of each class. So we have Setosa class. Its size is 50. Versicolor, its size is 50. Virginica, its size is 50. So whatever data we have three classes. So every class has 50 samples. So 50, 50, 50. Yeah. So this was all about summarizing the data. So dimension of data we saw, picking the data we saw, statistical analysis we saw, and class distribution. I hope you got it. Now comes the very interesting part, uh, that is data visualization. Very interesting. So as the name suggests, data visualization means we will be visualizing some data, means plotting graphs. So there can be two types of plots, univariate and multivariate. So in univariate, each graph will be focusing only on one feature. So and in multivariate, single plot will be focusing on all the features. We will look into it. So first, let's start with the univariate plot. So we will be using this box and whisker plots. So let's write the code for this. So what we will do, whatever data set we have to plot. So data set dot plot. So when we will be plotting, we have to specify the x-axis and y-axis and the kind of the plot we are interested in. So the kind will be the box. Subplots will be 2. Then we will be specifying the layout. 2 comma 6. So what exactly these things you just type, you just try to understand the output. In future I will be making lots of video, so one video will only be dedicated for data visualization, or only for box plots. I will teach you each and everything. So that's why it is a mastery session. uh, with me you will become expert in machine learning, it's my guarantee to. Definitely if you follow sincerely you will get benefited, I can commit that. And we will use pipe plot dot. So this is the code, so let's run it. Okay, sorry for typo. Actually, typing it will be subplot. So, oh, great. So now we can see a plot. So as we have seen, it is a univariate plot. Okay, and univariate we already know. For every feature we have a plot. So for sepal length we have a plot. For sepal width we have a plot. Petal length we have a plot, and for petal width also we have a plot. And this is a box, so I am just giving you a brief idea. So the box is representing the range, and the line is representing the mean average. So we can get an idea of the spread. So sepal length is varying from 5 to 6.5 for and sepal width is from 2.5 to 3.5, and the line is the average, horizontal line. And length, petal length from 2 to 6, kind of yeah, something like this. You get an idea of that. Now let's plot histograms. So it is very easy. So data set dot is okay for histogram, and pie plot dot show. So let's run it. Oh wow! So we have the histogram. So it is a univariate. So every feature will be having a plot. So path length, petal length, petal width. Okay, sepal length, sepal width, petal length, petal x-axis. So now how to analyze this plot and all, I will make a separate video. But today you learned how to plot. So that's the purpose for today, for this video. So this was all about univariate. Now let's also try to decode this multivariate. So in multivariate, in a single plot, all the features we will be analyzing. It seems very interesting. So let's try. So there is a function called scatter matrix. So we have imported, loaded it. I remember scatter matrix, and in this we will pass the data set. Then I will just plot it. Plotting is very easy. Pie plot dot show. Let's run it. Oh, great. So we have a single graph, a single plot. We can say that with all the features. Now, how to analyze it, how to study it, that is not the agenda for this video. That we will do separately. But you got an idea. You learned how to plot multivariate plot basically. So we did data visualization, univariate plots and multivariate plots. So whatever data set we had, the features we plotted it. Features we plotted. Very nice. Okay, great. So now let's jump into the fifth step, that is evaluating some ML algorithms. So definitely we will be making some more models. So before that, we will be splitting our data, because see, we have data set. So we will be splitting it into training and testing or validation. So 80% data we will be utilizing in training the model, and 20% of the data we will be using in validating the model. I hope you can understand. See, we will make a model, and we want to test the model, its accuracy. So for testing, we will be needing a data set. We will be needing. So what we will do, out of all the 100% data set we have, 80% of the data set we will use in training the data model, and 20% we will be using in validating the model. It is called 80-20. So let's do that. So we have to split the data set. Okay. So let's see how we will split the data set. So I am creating an array. Okay, so dataset dot values, whatever it will return, I will be storing it an array variable. Yeah. So what basically dataset values? It is ignoring all the labels, because see, if I talk about dataset is a data frame, it is containing labels also. It is ignoring all the labels. So in the array, I just have pure data with no labels. Now I have to split it into 80-20. X I will call. So whatever data, so in array I have the data, so what I will splice it. I will splice it completely and 0 to 4. Now what it is, let's try to understand. Okay, don't get confused. So see, we have already seen we have 5 columns. So let me get there to give you some intuition what is happening. Okay, so see, yeah, so this is the data we are focusing on, and here definitely we will be having the input and output. So the output will be this class, and we don't want it right now. So output will be the class and input will be these 4 columns. So here x, so here x is representing the input. So for input, what I want from all this data set, I want only 4 columns, not the last one. So that's why I am splitting it from 0 colon 4. So you know that whenever we split, so colon, so the colon after colon, whatever value we have, minus 1 we will get. That is range minus 1. So 0 colon 4 means we will get 0, 1, 2, 3. Fourth 4 we will not get. Okay, so here you can see 0 colon 4 means we will get 0, 1, 2, 3 means we will get 0, this staple length 0, 1, 2, 3. So 0 colon 4 means we are getting 4 features which we needed. Okay, so this is very clear after comma. So see, whenever we have a 2D array, you have to splice 2D array. So you will use the comma. So before comma is used to splice the rows, and after comma is used to splice the column. So if I talk about the rows, I want the entire row. So what it will do, it will get all the rows. So 150 rows, and columns only 4 columns. Fifth column it will ignore. I hope you got an idea. And y is the output. So in y also, I need entire rows. And if I talk about column, I just need the last column. So the index starts always from 0. So fifth means 4 because index is starting from 0. So 4. So y will be, if I talk about the shape of the y, it will be 150 comma 1 because it will be having only this column, class column, but rows will be 150. And similarly, shape of x will be 150 comma 4, 4 columns and 150 rows. I hope you got an idea. Now, so we what we did, the data set we had, we ignored all the label. So data set dot values. Now we split that into x and y. Now further we have to split it into 80-20. The x we have to split 80-20, y we have to split 80-20. So for that we are using this x train variable and x validation. Similarly, we have this y train and validation. Now, very easy. It's just a single line of code. So we have already loaded this functionality. Train test split. Yeah, split. Yes. And here we will pass the original array data x, y, and what ratio we want, that we have to specify. So test size I have to specify. The test size I want is at 20%. So I will specify 20, or it will be 0.2, 0.20 random state. So random state is basically used to shuffle the data. Okay, now let's run it. Yeah, so we did the splitting. If you want, you can print and test it out. You can print x train. You can use the head function to seek into it. That all you can do. We are done. So here x train is containing the 80% of the training data, and x validation is containing the 20% of the input. So it is containing 80 percent of the input, 20% of the input. Y train is containing 80% of the output, means 80% of y. and by validation is containing 80% of this, so 20% of this. So don't get confused. I hope it is clear. So if you are having facing difficulty, just pause it, just rewatch this particular part. You will get a very clear understanding. So we did the splitting. Okay, now let's understand how we will be doing the testing. Before building the model, let's understand what approach we will be doing to test the model or validate the model. So we will use stratified tenfold cross validation. So this is a technique. The name is stratified tenfold cross validation technique. So this technique is used to estimate the model accuracy. Now, how this technique works? For so basically, the data set, whatever data set we have, we split it into that 10 parts, and we train on 9 parts, and for every 9 part we will be doing one testing. For example, let me give you some idea. So from this X train, I took 9 samples. I gave it to the model. Model did some learning, and 10th sample will be the value from the validation. And see, whenever I will be doing the training, I will be passing both input and output. I will be passing both input and output. And when will be when I will be doing the testing validation, I will not be passing the output. So the idea is this: key 9 times I will pass both input and output. My model will learn. 10th time I will just pass the input from this validation set, input sample. Whatever output I am getting, I will compare it with the corresponding output which I already know, and the difference will be the error. And the goal of the model is to minimize the error. You are getting a idea. I hope you are getting an idea of how machine learning works. So in this way, what will happen after every 10 iteration, model will improve. It will improve its accuracy, because it will get to know it is generating an output at every 10 step, and it will compare it with the real output during the validation phase. It will improve. So in this way, it works. So as you can see, we are using the metric of accuracy to evaluate models. So definitely here our goal is to make model accurate. So what is accuracy? Accuracy is the ratio of the number of correctly predicted instances divided by the total number of instances multiplied by 100. So correct predictions upon total predictions into 100. So that is accuracy. Now let's build the model. This is very interesting. So as you can see, we have already loaded 6 models: logistic regression, linear discriminant analysis, k nearest neighbor, classification and regression trees, Gaussian naive Bayes, support vector machines. Now, how these work internally, what techniques they follow, what algorithms does, that is not the agenda of today's video. I will make independent video of each model that I will do. Here we just have to learn how to use it. So very easy. So I am making a list. The name of the list is models. Now what I will do, I will create a model. So name of the model and model I will append in the list. So models dot append. So I will append a tuple. So in tuple I will be having the name. So first model is logistic regression (LR), and I have to create this model. So we have already loaded this functionality, logistic regression, and here we have to pass some parameters like solver. Now what this is about, so that we will discuss in detail later, some other videos. Okay. Solver we pass, and multi-class, because it is a multi-class classification that we use. Oh, yeah. So we appended the, so this function, you can see this. So this is creating the model, very easy. So we are using pre-built model, and pre-built model are standard model because scikit-learn is a very standard library used even by companies. Second is LDA. We just have to pass the name. Great. The third one is KNN, K nearest neighbor. So just we have to create K near. So this is also very handy auto suggestion of you can say Google Colab. And next is cart decision tree. Now let's jump into knife base. So in 12th you must have stated probability, conditional probability, Bayes theorem. So it is something like that. Knife base is a probabilistic model. It is very interesting. I will cover. So in machine learning mastery series, just subscribe to my channel. What are you doing? Why? What are you waiting for? I will make you expert in statistics, mathematics. It's my commitment to you. Probabilistic model, you will get a feel what the probabilistic model is about. You support me, I will support you. You will be surprised. Yeah. Uh, so knife based done. Now let's look into the last model. Support vector machine. Yeah. So great. So we are done with the models. Let's run it. Whether everything is all right. Oh wow, it's working. So no typo mistakes. So now what we did, we created all the models. So along with the name and the model, we means we took a tuple name model and we appended that tuple in a list. That list is models. So models is a list. It is containing tuples of name and model. So six models we are using. Now what our goal is to select the best model. So first, what we have to do in order to select the best model, we have to calculate the accuracy, okay, accuracy of each model. So that is called evaluation. So let's do that. So we are making a list called results. So results will be the accuracy score that we will be storing here. Then names means name of the model that we will store here. Now I'm running a loop for name, comma model. So what it, oh sorry, it will model. So, yeah. So now what it will be doing. So we are iterating models list. So every element will be a tuple. So automatically we will get the name and model. So Python is so powerful. So yeah, so name will automatically get the name of the model in every iteration. So first iteration I will name will be LR and model will be the logistic regression model. Now I have to run the model. So evaluate the model. So we already know we are using that tenfold technique. So we already loaded a library stratified k-fold, and here number of splits is 10. Okay, the tenfold. So k-fold means you can take k to be any value. We are taking 10. We can take it 20, 12, whatever value we want. We are doing tenfold analysis evaluation. So random state is to shuffle and scoring. So our scoring parameter will be accuracy. Oh, sorry. Yeah, accuracy. Great. So we got this K fold. Okay. Actually, we have to take care of indentation. In Python, you know that. Now CV results is equal to- yeah. So this is the function cross val score. So as the name suggests, cross validation. And here we will pass the model. So you can see this model we are passing, and we are passing the X train, Y train. Okay. So training data we are passing X train, Y train, and CV is equal to K4, which we already created. That we are passing. So sorry, I did a mistake. So scoring accuracy will be here corrected, and here shuffle will be true. Make it more random. Now whatever results I am getting, so basically this cross val score, it will give me the result. So results dot end. CV. Now how the cross val score is working, all that I will make separate videos for that. Okay. Yeah, and in the names I will append names dot append. Now what I want to do, I want to print the result. Let me print the result. So, I am using this percent s colon percent f bracket percent f here. So this is a kind of a formatting in Python also. Here instead of percent s I want name, and in then I want accuracy. So accuracy CV. So accuracy will be the CV results dot mean. So because see what will happen, uh, it is a tenfold analysis. So it will test, basically it will validate with 10 samples. I want the average of that. I don't want 10. So mean means whatever result I am getting, I am calculating the average score, average accuracy, not the accuracy of each and every step. I don't want. I want the average accuracy. So that's why I'm using mean. Then I am also calculating the standard deviation. Great. Now let's run it. Let's try to see. Oh wow, wow, it's working. Congratulations. Now we have the result. So you can see logistic regression. We have an accuracy of 94%. Not bad. LD 97%, 97.5. Wow. KNN 95. CART 93%. NB 95. And support vector machine. Oh wow. 98.3%. 98.3% is a good accuracy. Great. So we should be proud of. We are making our first machine learning project, and we are getting an accuracy of 98.3 in SVM. So that's a great thing for us. Oh, okay. So now we will be selecting the best model. So definitely the best model is SVM. Now what we will do, we will be visualizing the results to get more clear understanding. Because see, just based on the accuracy, we can't go with the model. So for selecting the best model, we have to visualize. We have to plot. So let's plot. So pyplot dot box plot we are using, and here we will be populating it with the results, and label will be the name. So basically, results will be the y-axis, and the names will be the x-axis. And we are using the box plot, and I am giving a name also. Pyplot dot title. Great. And just let's plot it. Let's run it. It should be labeled. So type. Yeah, great. So we have it. So see, you can see we have six models. 1, 2, 3, 4, 5, 6, and this we plotted the results. So results. So here we have already seen. Let us suppose we are testing with 20% of the sample. So the plot is giving us an idea how that 20% is distributed. So if I talk about the LR model, the accuracy is spread. For some samples, we got accuracy of 100% also, or not 100 or 99, you can say 99. And for some samples, we got accuracy of 91% also. And the average accuracy, that is 94. So you can see the horizontal orange line. The horizontal orange line is the average accuracy which we printed. But spread you can see. So we are interested in the spread. So that's why analyzing the plot is very important in selecting the best model, because spread you can see. So the if you are going with the LR model, your accuracy will vary from 91% to 100%. Not good, because if your if some of the results we get with 91% accuracy, that's useless. If it is a critical application, let us suppose you made a fault detection algorithm and it predicted the fault with 91% accuracy, it will be a blunder. So that's why, so spread is not good. And SVM is magical. You can see SVM no spread. So SVM is the best model. From the plot you can see SVM is giving 98% result with no spread. Excellent. Hats off to SVM. And now you might be curious why it is doing so. What is the magic in the algorithms? I will make a video on that. That's great. So we have completed the that models and evaluation. Now the final step will be making the prediction. So as the name suggests, so in prediction, what we will do at random, we will just pass a data set, a sample to our model, and it will predict the class, which class this sample belongs to. So first we will be making a prediction, then we will be evaluating the prediction, whether the model which predicted the class, it predicted it correctly or it did a mistake. So first let's predict. So we are quite sure ki we will be going with the support vector machine. So SVC, okay. So gamma is equal to auto. Now what is this gamma and all that we will discuss in later videos. And yeah, so whenever we have to make prediction, we have to fit X train Y train. Predictions to model predict. So see what we are doing. First, we are making a model. We are once again making a model. So the model we are making is support vector machine SVC. We are fitting it. So fitting means we are training the model using X train and Y train. So we have the train model. Now we are just passing. So here we are when we are training, we are passing both input and output. You know that X is input, Y is output. So it is supervised learning. We proved it is supervised learning. We are passing both input and output. But while predicting, we are just passing the X validation, 20% of the data set samples we are passing, and whatever results it will give, so that will decide its accuracy. Predictions, okay. So here we will get prediction. So prediction will be the class. So for every sample we will have the class, okay, this sample belongs to this class, this class, this class, something like that. So let's run this. So great. So it did the validation. So 20% validation data, it did it. Now let's look into the final part, evaluating the predictions. Very interesting. So now let's do it. So print accuracy score. Um, Yeah. So it's very straightforward. So accuracy score is a pre-built function. We have already loaded it. I can remember. It will be small. And see, calculating accuracy is very easy. By validation is containing the true values, the value which we already know, and prediction is containing the values which is predicted by the model. What accuracy score will do? It will compare it because it will be sequential. We have the y validation means we know the true value, actual value, and this is the calculated value for every 20% of the sample that we will compare it and we will calculate the accuracy. So we will print it basically. So first we will print the accuracy score, then we will print the confusion matrix. Now what this confusion matrix and all that, for this video you just remember it. Okay, so in order to evaluate machine learning model, we use confusion matrix. What exactly it is, in later videos you will get to know. So here also we are passing this prediction. So we are what we are doing, we are printing the score, accuracy score. Yeah. We are printing the confusion matrix and also we are printing the classification report. Okay. What this classification report and all that we will get to know very soon in later videos. Let's run it. Oh, sorry. You have to actually spelling. It's a typo. Okay. Prediction. See, I got excited. Uh, yeah. Now let's try to run it. Oh wow, we got the result. So see accuracy, you can see. So in the validation, the accuracy is 96%. Not bad. Not bad. In validation accuracy 96% is good, and you can imagine just 150 samples, and you know in machine learning we need lots of data. Instead of 150, if it becomes 1500, accuracy will increase. If it becomes 15,000, accuracy will increase more. And this is the confusion matrix. Now what it is and all that you will get to know very soon. And this is the classification report. So yeah, so we are done with the project. So congratulations, you made your first machine learning project, and with a very structured way, in a very structured way, and you definitely got to know about many of the new concepts. I hope you liked it. So what are you waiting for? Please like this video, comment on it, share it in your circle to your friends. Let us make a community of machine learning mastery, community of experts of machine learning. Yeah, share it in your circle. Subscribe to my channel Nkool Marwadi, and do let me know in comment if you want a video on any particular topic. Do let me know. I'm very much. I will come up with a video on that topic. Thanks again for your time. See you later.